Hello, in this video we will perform hypothesis test in STATA. For that we will begin with a clearer as usual. I will select three codes here, and I have set observations to 100, set seed to 1 to 3 4, and these can be any numbers, but for a caveat, this seed should be the same number for the replication of the results. And now I will generate three variables: age, gender, and area. Age is continuous variable, gender and area are the binary variables. And to be noted that these variables are hypothetical and I have generated it myself. So these data are not collected from the survey. Now I will generate these variables without going through their technical details. I will run this code, and we have, I think, three variables generated here. It's age, gender, and area. So now I will jump into the hypothesis test. First of all, let's begin with one sample t-test, and for this the variable must be continuous. This is the fundamental requirement for it. And the second, I will summarize age, since we only have age as continuous variable in our example, and we will look on the age or the mean age. We will only look over the mean age because t-test is the test of mean, and its mean is 50.2, and we want to test if mean is 40. Now if mean is we want to test if the mean age is 40, and here our null hypothesis is age equals to 40. Our alternative hypothesis are age is not equal to 40. This is two-tail test. Age is greater than 40. This is one-tail test, and the name is right-tail test. And age is less than 40. This is also one-tail test, but the exact name is left-tail test. But these two tests are popularly known as one-tail test. And the command is t-test age equals to 40. Let's run this. And in this part we will only observe these values, p values, and as we have been discussing that the mean is 40 though, and we want to test it. This is for the test purpose, and we test against the actual mean. And here and we are testing that the actual mean is less than 40. In this case, we cannot reject the null, since we fail to reject the null since the p-value is greater than 0.05. This is the conventional and hypothesis testing rule. And the second is that we are testing that mean is not equal to 40, and for this we will see that if p-value is less than 0.05, since it is less than 0.05, we reject the null, means that the null is mean equals to 40. We reject it, saying that 40 is not the actual mean. And at the last, this is actually the right tail test. In this case, it's testing that mean is greater than 40 and its p-value is 0.05, less than 0.05. So in this case also we reject the null, and we conclude that the actual mean is greater than 40. And similarly we can do the test for age equals to 50, and if we run this code, then we can only observe these p-values. In this case, all the p-value is greater than 0.05. So we can conclude that we fail to reject the null. It means that the mean age is 50, or it's near 50. So now let's go to independent sample t-test. In this case, the fundamental requirement is one continuous variable and one binary variable with only two categories. For this, let's test about gender. Uh, let's begin with tabulating gender, TAB gender. In this case, there are only two categories. It's male and female. Since it is hypothetical data, 64% are male and 36% are female. And here the null hypothesis is no difference in age between male and female. This is the test we want to do. So now let's carry out this test. The syntax is t-test age by gender. If we do this, then in this case also we will observe this one, this line, and the last these p-values. And the main thing is that the null hypothesis is there is no difference, means that difference must be zero. Difference 0. And in the first part, we are testing that if the difference is negative, it means that difference is negative means that um, mean age of female must be less than mean age of male. In this case, age of female is not equal to age of male, and in the last case it is age of female is greater than age of male. And we only look over these p-values. Since the p-values are greater than 0.05, greater than 0.05, greater than 0.05, in these all three cases we fail to reject the null. It means that we fail to reject that the difference is 0. So we can also observe that their age is almost same. It's 50.77 for female and 49.875 for male. So their difference is almost 0 in the actual sense also. So this same result has been concluded by this test, and we can do the same analysis by area. If we do the same analysis by area, the code is t-test age by area, and the null hypothesis is no difference in the age in Williamstown and North Adams. If we run this command, then we can observe the results in the result plane. As usual, we will look over this. Its null is difference 0, and in this case it's saying that if the difference is less than 0, then it should be that North Adams average age is less than Williamstown average age, and in this case North Adams average age is not equal to the Williamstown's average age. In this case, North Adams average age is greater than Williamstown average age. So now we can observe that this is significant at 10% but not at 5. Since we can also observe it as at a 10%, we can say that we reject the null at 10%. In this case, this suggests that the average age in the North Adams is less than the average age in the Williamstown. And for these two cases, since it is greater than 10%, and this is also greater than 10%, so we fail to reject the null hypothesis. And we also can observe this phenomenon from here. The average age in the Williamstown is 53.45 and North Adams is 46.81. So in this case, the average age is less in the North Adams compared to the Williamstown. So the t-test is also indicating the same. But previously we have compared with the 5%, but now we have compared with the 10%. I think that it's not a problem, and we can compare it at 1%, 5%, and 10%. So these three are the convictions or the traditions in the hypothesis testing. And let's begin with the chi-square test. So now the chi-square test is called a non-parametric test, and the test that we have done earlier, the t-tests, they are the parametric test, means that they have certain form of distributions, and these variables are, and the main variables of or the main variable of interest is continuous. But in the chi-square test, it's not the case. In the chi-square test, we test the binary variables such as gender and area, and for this we need to simply run the command tab gender area comma ci2. It's for chi-square test, and the null hypothesis is that no relationship between gender and area. If I run this command, then we will see in a result plane we should only observe this p-value, and since it is greater than 0.05, we fail to reject our null hypothesis. Null is failed to reject, that we fail to reject the null, or we don't have sufficient evidence to reject the null, so there is no relationship between gender and area. This is a simple demonstration of chi-square test, and we can also have more advanced form of this test such as Fisher's exact test and so on, which I have not covered in this video. Thank you.